Hello, we're at GASP Engineering, and for our project, we're doing the stand-and-go electronic walker. I'm Daniel.
I'm Sebastian.
Jose.
So we used a decision matrix to compare the various project ideas that we had, and we found that the stand-and-go walker matched our interests the most, and that's why we decided to go with it. And for the introduction, falls are the leading cause of injury-related deaths in the world for people older than 65. So we wanted to tackle this issue. We wanted to tackle this issue in a specific way by addressing the fact that standing from a seated position is often challenging for elderly people, and this is where most fall injuries happen. There's always a potential risk of standing from a seated position without assistive care for elderly people. And there's also a risk to the caretaker themselves from being injured. So there's this need for design in this aspect. Most elderly people want independence and mobility in their lives, and we find that this walker design will improve their lives and help with that issue. Injury also may occur in assisting the patient as well without the walker design, and we want to address that. Current solutions on the market don't really address the ability to stand from a seated position. Most are independent and fixed in a certain spot, and they don't give the mobility to the user or the independence of an elderly person. For example, if an elderly person wanted to use the restroom from a position without assistive care, they would not have that ability. So we want to tackle this by coming up with a new idea and bringing that to elderly people.
Hi, and so our idea is we want to design a new and improved walker. So we want to keep the basic design of current walkers. They've been around for a long time, they're very reliable, everyone knows how to use one. Except ours will include 2 linear actuators, which are motors on each side of the walker. These 2 motors will support up to 200 pounds and will assist the user from sitting to standing. We also want to have a very user-friendly interface, since our target audience for this walker is the elderly and disabled. We want to keep the buttons as minimal as possible, make it as easy to use. So another important thing in our design is we need good brakes. As the user is standing, the motors are pushing up. The user might not be totally balanced. So we need good brakes to make sure that the walker itself does not move as the patient or the user is standing up. Another feature we're going to include is the emergency SOS buttons on all the legs of the walker. If for some reason the user does end up falling, the legs of the walker will be within reach of the user. They'll be readily available to press, which will then send an alarm to anyone that's nearby to assist the user up and provide any care needed. And so the constraints that we have for our project, our design, is that current walkers are very light, very easy to use. Many elderly people can easily lift one up, put it in their car. Our design, of course, will not as light as current walkers. We'll have to take into account batteries, motors, but we want to try and reduce that weight as much as possible. We also want to keep the walker as strong as current walkers. Current walkers can support up to 300 pounds normally. We want to be able to make sure that our walker can do that as well. We don't want to make the buyers feel like they're losing out on a feature there. We also want to have batteries that are long lasting on our walker. We want to have the user be able to use this all day without having to worry about, is it going to die? Do I have to recharge it? They need to be as if they're using a normal walker that didn't need to be charged. And so objectives we have for this project are, there's a lot of coding. We have to design algorithms for the linear actuators. When you press the button, we need to make sure that sends the proper signals to the actuators to go up or down when they're needed to. We also need to make sure that when those motors are going up or down, that the brakes are set and secure on the wheels. We want to make sure there's no falls. We also need to make sure that the feedback sensors on the motors are working appropriately. We do not want the motors to become unbalanced as the user is coming up. We want to prevent falls. And so for our hardware block diagram, it's pretty simple. We have our power over here, which consists of two 12-volt batteries. And then we're gonna have to convert those 12 volts to 5 volts for our microcontroller. The 12 volts will go into the linear actuators. And then from there we have the data from the microcontroller to the motors, the feedback, and the buttons. For our software, so we start here, you press, the user is initially sitting, they wanna get up, they press the button, then the button will turn on the red LED, which signifies the brakes are set and it's ready to go up. They'll press another button to go up, then that means the blue LED turns on, that means transformation is active, it's currently going up or down. And then once it's done, the green LED turns on, meaning you're ready to go. Over here, same. So as the linear actuator is going up or down, it'll wait for it to be balanced. We do not want the two linear actuators to become unbalanced. So it'll, once you press that button, it'll wait. Once it's balanced, it'll go up or back down.
Okay, so Jose and Daniel talked about how it's gonna work and how it's gonna, all the problems that that we're gonna focus on. So I'm gonna talk about how we're gonna work on getting into solving those problems. So our schedule actually is gonna start at the end of this semester. We are gonna be doing some research from not only like some cases, but also doing research on the data sheets on components and all the electrical components that we're gonna be using. That's gonna take us until end of the year. By the end of the year, we are planning on having all the components already in our possession. So that way, by the beginning of the next semester, we'll start doing the implementations. Starting the next semester, we're gonna start with phase 2. Phase 2 will consist of the implementation and creation of the algorithms of the electrical components. So we're gonna start first with the safety system. We wanna make sure that that works first of all. Then from there, testing it and prototyping it, we're gonna jump into the linear actuators. The linear actuators is the main function of our product. So that's a fundamental part of our scheduling. It's gonna take around 3 weeks. So if we don't get into that time frame, we have to extend that time frame and then work on our sensibility, force sensor, sorry. And after everything is working and we know that it works, we have the algorithms, the functions, we are gonna then jump into the integration part. That's where we grab our design and put everything together. We grab the walker and we put the linear actuator, the force sensors, the user ID to make sure everything works together. After the integration of everything, we're gonna be jumping into the testing phase of the design. Testing phase of the design is gonna be composed of 2 parts. The first part is gonna be just testing the components, they work in harmony. There's no malfunctions, there's no, everything goes together. After that, we're gonna be jumping into the second part of this phase, which is the test subject. So in order for validation of this product, we are gonna be testing with some human subjects. Who's gonna be the human subjects? It's gonna be us. It needs to be, it's gonna be able to work with every single one of the members of GASP engineering in order to be able to pass verification. If it doesn't pass it, we need to go back and rework the components. In conclusion, our budget, our budget is gonna be composed of like the main components, which are the linear actuators, the battery, the microcontroller, aluminum tubes for support, alarm system, which is gonna be composed of of a buzzer, a button and a buzzer, and miscellaneous, which comes with cables, resistors, or whatever other electronic element that we are gonna be needing. In total, our total budget, expected budget is gonna be over 750. So we expect not to pass over that. Now, in conclusion, we hope that our product actually like helps us, helps help society by helping elderly and disabled people getting up and down, bring them more independency to them, and have them a more enjoyable life. And also help out all the assistants and nurses in hospitals and clinics, so they don't get more back